All right, good morning. All right, we have a report out on a 2P activity, and I believe we also have an A3 report out from one of the workshops, and so I'm going to hand it over to Troy to kick us off.
All right, good morning, everybody. I'm Troy Beyer. I'm with Simpler Consulting, and I worked with a team this week on a 2P, which is a process preparation event where we focus specifically up at the North Water Treatment Plant on the filter building, the flock and sedimentation buildings. So the team did a great job this week. One of the challenges is that we were at a 30% design point, but they did an awesome job trying to really think about how we could do things differently and had the what if in their mind as opposed to the, yeah, but we can't do that. We've already done that. So they did a great job.
So I'm Zach Alabasi, and just in case some of you don't know what the NTP is, it's the North Water Treatment Plant. This is the new plant that's going to be built at the Ralston Reservoir. The reason we did the 2P is we've reached the 30% milestone of the design. So it was a good time to kind of pause and evaluate input from stakeholders, listen to the voice of customer, the folks that are going to operate the treatment plant in the future, and possibly look for more efficiencies. So my job today is to introduce the great team we have. We had people from a lot of disciplines. We had engineers, we had I&C folks, people from operations. So going through the picture from left to right is David. He's with AECOM. Justin is with Denver Water I&C. Tad Kogan with Asset Management. Jenny Miller is with Corollo Engineers. They're mainly focused on the I&C part of the treatment plant, the new design. Whitney with Denver Water I&C. Hillary with CH2. Jason with CH2. And of course, Troy with Simpler. Adam with CDM Smith. Myself, and then Boyd with Kiewit Construction, and Casey Clark with our Denver Water Electrical Engineering Group. These are the folks that were involved directly in the 2P process, but there were a lot of people that provided support. They really made it easy, and I have to say that the food was great. Everybody had good things to say about the food. So. But I'll hand it over and let my team talk about the approach we took for the 2P and some of the great things we came up with.
Thanks, Zach. I want to give special thanks to the North Water Treatment Plant design team. They put everything together very well, especially the engineers that did the current design. Is very robust, didn't miss a lot of details. We had a hard time developing new things. Also want to give a shout out to all the water treatment plant personnel for voice to customer, giving us their feedback on what they want to see in the new treatment plant. So that was very important. And also want to give a shout out to Troy Beyer and Austin Steckler for facilitating this as well. They did a fantastic job. The reason for action, why we met, was to determine the selection criteria for equipment to meet the Northern Water Treatment Plant project goals regarding modularity, accessibility, maintainability, and of course safety. The aim and the scope was to identify critical assets within the filter building and the flock sed, and determine the process flow, maintenance, ergonomics, reliability, and safety considerations.
So on Monday, we spent a good portion of the morning, actually about half the day, taking a look at the voice of the customer. So all the treatment plants were polled for their delighters, their performer, and their basic needs. So the team spent a good majority of that time using this Kano diagram to ensure that we took a look at everything that they wanted, needed, and really took value in the voice of the customer so that the design of this new plant takes all their voices into account. Then we ran through 9 different SIPOCs using the 3D model, which was very helpful. So obviously we're designing the plant. We can't see it or walk through it. But with the 3D model, at least for myself, and I believe the whole team, it was very helpful to be able to walk through, see what things are looking at now, how things will work, and so we walked through that. It was very helpful.
So as we looked at our current state, we went through 15 different design plans. And when we looked at those, there were a concept of man, method, machine, and material that we wanted to look at, the 4 M's. So as we looked at that, we kind of went through these whole design packages and looked at, where pinch points might be, where safety considerations might be, how are we going to move material in and out, how are we going to read the readouts on the instrumentation. If we remove one of these large 36-inch valves, where are we going to stage that so that we can replace it or do any type of repair? So we wanted to ensure safety, as we've talked about. We also wanted to increase modularity, and also, as we're doing this, we really don't want to give up anything, but we don't want to increase cost as well. So cost was a significant driver. As we looked at, let me go back, sorry. There we go. So as we looked at redundancy, we also wanted to look at how much redundancy we had. So when you look at redundancy, it costs money and it costs square footage. So it also costs maintainability and operation cost in the long run. So we really wanted to reduce that as much as possible. So if we could, configure down to 1 PLC versus 2, things like that, those are things that we looked at. We looked at the consequence of failure based on environmental impact, safety, productivity, quality, things of that nature, and made sure that we took all those into consideration before we made that decision. And then also, as questions come up through the week, we wanted to address those or any concerns so that, if something came up, we would always go back and address it, and then we made sure that it was corrected as we went through the process. So we looked at 19 different user personas. So basically, anybody that's going to be in this plant or working in or around this plant or even visiting this plant. So we wanted to address their wants, their needs, and their fears. So operator, basically, you're going to have to address all those concerns. Water quality technicians, we've got instrumentation and control. And then our outside people, fire department, EMS, first responders, vendors that are going to be on site. We wanted to address their needs, wants, and fears as well.
So the design team left us with a really solid design that we were tasked to challenge. So we came up with 7 different ways to challenge that design. We looked specifically at the 4 different process areas within the 2 buildings and really focused on providing alternatives to the layout of process equipment, looking at the voice of the customer and trying to find improvements upon what they gave us to look at. Examples of that are we took the idea of in the filter gallery, what if we lower the slab and instead of burying all the headers, have it above the slab? How does that compare to the existing design? Kind of out of the box thinking like that. A lot of those really drove cost way up, so we took the decision that that wasn't the way to go, but we kind of left everything on the table. And then once we had our 7 different ways for each of the 4 process areas, we ranked each of those. And as you can see, there's some of them, there's only 5 because we were really challenged to come up with 7 alternatives for each one. But we ranked each of those alternatives against each other and against the design process to try to come up with some improvements. So this is looking at those improvements with the filter gallery. So we came up with a hybrid design layout. And speaking specifically on the filter gallery, we learned that we could actually improve a lot of the flow of personnel and equipment simply by moving the electrical enclosures in line to the front of the gallery. Gives them smooth access to the PLC enclosure, the UV panel, the water quality panel, without having to interact deep into the process equipment unless it's a more specialized electrician or something. We also looked at the central pipe gallery, and on the east side of the building, a lot of the decisions changing the plant from 150 to 75 MGD hadn't been solidified. And so the team was able to really solidify a lot of those decisions and actually eliminated some of the extra equipment or extra space, reroute some piping, and we think that we actually realized the savings of around $500,000. Let's see, I think.
Thanks, bud. So just as Whitney talked about with the filtration process, we did the same thing with Floxed. So we looked at the sludge gallery and also the rapid mix or Floxed process. So in this one, we removed 3 sludge pits, eliminated confined spaces. How huge is that? I mean, as far as safety. So anytime you can remove a confined space, it's great. Reduced the gallery width, so we kind of shrunk the square footage down, and improved sludge flow meter access. On this side for Floxed, we added a tunnel for flood mitigation. There was a lot of concerns down here on this end, especially with raw water coming in, that there was possible flooding, so we eliminated that. Equipment access, we deleted 3 watertight doors on this side, but we still kept these on this side, and we didn't actually reduce any access points by doing that. We can still perform the same maintenance and operability that we would with 3 as opposed to having 6. We centralized the water quality panel. So we brought 3 independent water quality panels for this process and shrunk it in. So now we've only got 1, so it limits the mobility back and forth. We also looked at the PLC. I talked about redundancy earlier, and instead of 3 independent PLCs, 1 for each rapid mix, we condensed that down to 1 PLC. And by changing our process and our procedures, if we lose a PLC, which Justin, told us we've got about a 2 to 3 hour mean time to restore on that we can actually go now and put that process in local, run it manually, and then we eliminate the huge cost of having 2 additional PLCs in that process. We reduced the gallery width, and we also eliminated skylight. So a significant cost reduction there. So our deliverables for this week, first and foremost, we enhanced safety. We eliminated a lot of confined space. We made maintenance easy. It's one of the big concerns with Steve and his group when they come on site. We want to make sure that there's no pinch points, so that we've got proper access, and I think we've done that. Uptime and reliability, first and foremost, we want this plant to be reliable at all times. And then how efficiently can we restore an asset? That goes back to that mean time to restore. If an asset or a process goes down, we want to make sure that we get it back up and running in the shortest amount of time possible, while not jeopardizing safety, quality, or efficiency. And we were able to obtain a lot of savings without giving up any water quality, maintainability, or modularity or safety. So like I said before, we gained a lot without having to give up anything, so that was a good week.
So some of the insights for the week, I mentioned it before, the engineering team put a lot of good effort, design ideas. It was very hard to come up with something new. So that was one insight, having a hard time to come up with any new designs on top of what was already created. Good 3D visualization. They had a 3D model, so we could actually walk through the plant on the computer and visually see what pinch points were, what things were in the way, confined space, and how do we mitigate that. Also, clearly evident the design was very good, and the Flock and Sed facility can flood. So we found that out. That was a big nugget that we got out of it. So with that, we'll turn it over to questions.
There are a couple of people I forgot to mention that were on the team, Steve Holder and Patty Brubaker, who can't be with us today, but Steve stepped out of the room and we took the picture, and then he was back. So anyway, they were on our team and they were really instrumental. Any questions?
I don't have a question, but I just wanted to say that it was part of the MVP design team, and I was up there to watch the group and teamwork. These guys took a design, and we estimate probably over $500,000 in savings just in construction, and then also a mountain of life cycle safety and just efficiency baked into the design going forward now, that the organization will take value from so long as the facility is up and operating. And just really want to kind of credit and commend these guys, because unless you're there, I don't think you see how hard they work and how engaged they are 8 hours a day, every single day. And it's exhausting. And so it's important to note that they did a great job.
Great question, and it's always a struggle. It's a trade-off, and and they're all priorities, whether it's safety or ease of operation, ease of maintenance. Like some of the team members touched on, it's a great design to begin with, and we really touched on quite a bit of those aspects throughout the design itself. So I don't think there were, we found a lot of, if you will, major modifications or changes that we can make, but simple things like eliminating the sludge pits, I think that was kind of more of a low-hanging fruit, where we felt if we can move the flow meter out of this pit, it's one less place that an employee has to kind of climb a ladder down and do the work in a confined space. So little things like that that add up to not only cost savings, but also safety and ease of operations. Did I answer your question?
You did.
Okay.
Sounds like a great result. I don't know why you guys are playing down.
Well, thank you.
And I'd like to say it was really nice to have, the right experts in the room. For example, we worked really hard discussing eliminating the tunnel that connects the front of the Flockenstead to the back and the costs related to eliminating that tunnel. We would go back and forth on a decision, but it was really nice to have David in the room as the architect, because he would say, well, you can take the tunnel out, but code says you have to add a staircase now. And so we had to balance the cost difference of the tunnel versus the staircase. So it was really nice to have those kind of people in the room to help answer those kind of details very quickly.
They were very receptive as well, even the design engineers. I mean, anytime you come through and you bring them in towards 30% design, you've got a lot of the design engineers present. I mean, you're kind of wondering how that's going to go, right? But they were actually very receptive and, very adamant about, hey guys, show us what we can do better here. So we've got a really good design team over there, and they're doing a great job. So I'm really proud of them. Really proud of this group too. Brought a lot of good questions to the forefront this week. So they did a really great job.
I also want to add, as far as the design team, they kind of kept us in check. The executive team, Peter, Russ, Bob Mahoney, they come in at night and kept us in check by saying, hey, Moffett is our backup. So as far as the redundancy goes for the Northern Treatment Plant, and that was a big decision that we made in the CBA as a group. And so wanted to commend those guys to keep our mind focused and straight on where we needed to go with that. So.
All right, we have one more report out for you guys. It's a personal A3 that Steve and Joel took upon themselves to work on.
Good morning, everybody. So Joel and I incorporated an A3 together, and it's over the small valve maintenance program that I inherited this year. So our reason for action is we plan on operating over 14,000 valves. That's our goal. Joel's part of it was at night, he's a graveyard foreman, we're going to go in and we're going to operate valves in busy intersections. We're going to use a Barricade company for safety. This hasn't been done in the past, and that's going to really help with when we have main breaks and different issues. As far as my part on there, the system quality part, my part was to eliminate water quality investigations on a monthly basis. And by doing that, we're going to incorporate water sampling with the small valve exercising program. So right now, our current state is, when people go out on emergencies, valves are, there's debris in them, there's issues, the lids are frozen, so it's taking a lot of time. So by exercising these valves, that'll eliminate a lot of problems out there. So, yeah, basically, last year, there was about 8,000 valves that were exercised, and none in busy intersections or anything like that. So that's where we're at now.
So now what we're trying to do, our target state is we want to go through all the intersections and all the valves that we can get to, try to get the 14,000 this year and maintain them, and turn all the valves that are in need of repair to T&D so they can get those repaired, and reduce the number of water quality investigations by 25. Steve take care of all those water quality investigations, and he does get quite a few of those. Our gap analyst, let's see. So the valves that we are trying to target have not been exercised or operated, and the problems are we have to back up. We try to isolate main breaks, putting additional customers out of water. So our root cause to right now we have no plans. We have no plan to exercise those valves right now in those busy intersections, because day shift, it's really hard for them to get to those valves during traffic hours, and we did not have any of those trucks at our disposal to do that. And of course, we didn't have any standard work.
So our solutions approach, if we create standard work, we can get consistent results and efficiency. We're going to define the valves that are in these busy intersections that need to be operated. By doing that, we'll have data and what valves have been exercised. And then we're going to incorporate the water quality sampling with the valve exercising, then that'll reduce the amount of monthly water quality investigations by 25%. So our metrics are 14,000 valves a year. Right now, it's 0, and our target is the one, current 0. We have 3 fully operational vehicles. When we started this, we had 0. We had to put a lot of money into getting those back up to operational. That we some programming and different hydraulic stuff we had to do to the trucks. Right now, 2 of those are running. We have 1 that needs some extra work. Operating valves in busy intersections, initially none, and our target is 1, current is 0. Initially, no one was trained on these valve trucks. Our target's 22. So far, we have 12 people trained. As far as training for sampling water quality, we had 0 to start. We needed to train 2, and both the people have been trained. So our initial water quality investigations are approximately 35 a month. We want to reduce that to 25, and over time, we'll see if we can get there. So our completion plan is, we found we had a lot of hurdles. We got thrown, how are we going to get this all done? 14,000 valves with 2 people. We need a lot of help with IT as far as completion forms, routes, different things like that. So we met with Tom Grable and his group, and we decided to make it a REI event, get the right team going, to get this accomplished. And then we're going to have to train the remaining 10 people on operating those valve trucks. We'll have that done by the 25th of June. So basically our insights were this whole A3 process, how to break things down and get a solution to the problem. I mean, at first we were thinking, oh, we can handle this, we can figure this all out. It's not that easy. We saw that we had a bigger issue, and if we want to do it right, then we're going to have to go to an REI event and get the right people, right equipment, right plans, different things like that. So it really helped us. And You know, Austin and Christie, they helped us a lot with building those A3s and looking at the different process. I want to thank Joe and Lanny and the different guys from emergency services helped us out, and IT people too that are helping us out. So I feel we're going to have a great program once we get this all figured out. We're going to do it right. Good. Any questions? Okay.
What do you expect to have come out of that RIE? Are you looking for that to be where you come to your standard work and how you're going to execute and all of that?
Exactly, almost from scratch. Standard work, how we're going to generate and create the PMs for the routes. We're going to determine how is it safe to have 2 people per truck, 1 person per truck, dealing with going through busy intersections, how we're going to have a safety and traffic plan, a lot of things like that to get those 14,000 valves completed on a yearly basis. Zach?
Your long-term goal is to exercise those valves, all 14,000 every single year, year after year?
Well,
Or can you skip?
there's approximately 70,000 valves that need to be operated. So we have a 5-year plan. So we're thinking if we can get 14,000 a year, that'll get those 70,000, and we're going to work through either quads or different types of map pages to route most efficiently how to do that.
Is there any thought on kind of determining which ones are most critical, maybe revisiting those more often as opposed to others? This would probably optimize the process. Any thought of that?
Yeah, I think once we get into this and we'll get data and we'll know by age of pipe, age of valves, areas, we'll know the problem areas to keep those maintained, a higher priority.
Do you have a good understanding of the costs and impact of each water quality incident?
I know that, based on time, manpower, things like that, an average water quality investigation is about takes about 2 hours. So when we're out there on site and we're taking care of the valves, we're also going to be maintaining and doing maintenance on hydrants while we're out there too, that we didn't add. That's part of the standard work. But we're getting the sampling. We should probably reduce that in half, I'm guessing, that time of, manpower and whatever that cost is.
Steve, doesn't this also have some implications for outage hours for customers because we can get a better shout?
Yeah, exactly. That's one of our biggest goals is to reduce that outage, for our customers, reduce the amount of erosion or any property damage by being able to isolate these breaks a lot faster, and also safe for the guys out there doing that work, and in traffic, and they'll be able to isolate these so much simpler. And we won't have to back up on other valves, putting more people and more customers out of water. Okay.
I'm not very good at math.
Mm-hmm.
It seems like 14,000 valves in a year is quite a number on any given day. And I'm trying to visualize it. How many valves are in a busy intersection?
Approximately 6 to 8. And we've been, that's another thing, we'll do some metrics on time. Right now, with just operating the valves, it takes us approximately 15 minutes per intersection to pop those lids, exercise the valves. Not a long time. We're thinking with adding the sampling on the hydrant and the maintenance, it'll probably add the time to about 20 to 25 minutes per intersection.
Just curious, when you operate them, do you go fully closed, fully open, or the other way around, or you just try to move them?
Yeah, we exercise them. So what we'll do is we'll operate them closed, then we'll operate them. And normally what we have is on the trucks, it's built-in programming, and it has exercising mode. So we put that on there, and it'll take the valves down, up and down. So what we're trying to reduce is the torque on that valve, especially, that helps with injuries too when people are out there trying to shut these valves. Try to get it down to under 100 pounds of torque.
Does your equipment have the ability to tell you if the valve is actually moving? You don't have a break between the operator and the valve itself?
Yeah, it'll tell you exactly how many, and it'll give us good counts too. So, and we know what size the valve is, how many counts we should have. It does all that.
So any defective valves you find you generate work orders to replace?
And that's going to be another issue that's going to be when we really get this going and we have a good plan, that's going to generate a lot of corrective maintenance, a lot of work requests. So, and our T&D crews know that's going to be coming. But over time, we'll have a good sound system.
Last question from Russ.
Russ? Okay.
This is really a neat program. I was wondering, can you marry this over to the treatment plants where they have thousands of valves of various sizes as well, or would we struggle with our exercising programs?
Sure. Yeah, we could incorporate that to, yeah.
We can help you out there.
Oh, as far as giving us the data and.
Using the same techniques that you're developing. Sounds like this could be a natural crossover event.
Sure. I think that would be a great idea. Yeah. Right now it's just for our distribution system, but yeah, we could move it into SOS and treatment.
For Phil Malone, who's working on distribution system optimization program for Mississippi Water. It's going to be something in the phase 3 report. This is a perfect example of how we're using the same rating system. So if you haven't reached out to him, or I can, if you didn't know about this project,
Yeah, I've talked to Phil a little bit about it, I think about a year ago. So yeah, we can talk to him some more about it and tell him where we're at. I think that'd be good. Well, thanks everybody.
All right, so in both of these examples, one was a design example, one is a, out in the field work example. The way we at Denver Water practice continuous improvement is really all down to getting the right people together with the right information and just giving them the time to work that problem. And I know that I say that out loud and it sounds very simple, but it's not that easy to do because we're all busy with a lot of different things. And I would encourage you to get back with your teams and think about how can you carve out time to allow them to work on a specific problem, a narrow problem, and get the right people together. I guarantee you things will get better and better as time goes on. Thanks very much. Have a great weekend.